Okay, the next vocab for the day is altitude. And I know you guys all know what altitude is because that's the height of the triangle. And we've done all those area equals base times height times 1/2 for a triangle so many times that I know you know what height of a triangle is. But just to review, the altitude of a triangle is always runs from the vertex straight down perpendicular to the base. And we can draw an altitude from any vertex to the opposite side. It doesn't matter which side we work on. Well, if we do all three of those, they are going to intersect at one point, and that point is called the orthocenter. So that's what we're learning today. So let's find the orthocenter on this particular triangle. So how do I make sure that when I draw a perpendicular line, it runs through a certain point? I have to draw a line perpendicular to this base that also ends up running through that point. Remember, I need 2 points on this line that are exactly equidistant from that point. In order to do that, I'm going to set my compass so that it is at the point of that vertex. And it's going to cut across this base. Now these 2 points are the points I'm going to work from when I make a perpendicular bisector, right exactly halfway through the middle of those. Since those are both equidistant from that point, the halfway point, the perpendicular should run through there. So let's do that. So I'm going to go from that point. I'm going to shorten my compass up a little bit because I don't need it quite that wide. I'm going to do the same thing from this intersection point. I'm going to take my straight edge. All 3 of these points should line up. So that is my altitude because it is perpendicular to the space and it runs through that vertex. Okay. Let's flip this around and do it from another side. We'll use this as our base. Same thing, I need it to be perpendicular, but I need my perpendicular line to end up running into that point. So I've got to get 2 points down here that are equidistant from this base. Now, it's so close right there. I'm going to give myself a little extra room. I'm going to draw the ground that my triangle is sitting on. So I can bring my point on out here. I can give myself a little more room to work because I just can't get a good arc in that tiny amount of space. Let me widen this out a little. I'll bring it all the way over here. Now I've got some good points to work from. So from there, I'm going to bring this in a little bit. And that intersection point. And from that one. Okay, so now I have 1, 2, 3 points that are all equidistant from both of those. So when I connect them, it definitely should make a perpendicular through that point. I must, you know what I did? I must have gone to the end point instead of to my intersection point like I was supposed to. Check myself over here. Yes, I'm good there. I'm good there. I'm good there. Okay. Let's try again. I knew I had something messed up. Right. That looks much better. If I were to continue that line on down, but I don't need to. Alright, so now I have that height. Okay, I can turn my triangle again, and I can make a height through here, or an altitude. Okay, same thing. Oh, I'm going to end up in the same situation again, where I don't have enough room to work here. I'm going to have to draw myself some extra ground. Alright, so now my triangle is sitting on the ground over here. Give myself a little extra room to work. Okay, so I'm going from this point. My goal here is to get 2 points that are equidistant from that point to work from. So I'm here and here. Actually, I'm going to make a blue dot here for you so you can see it. These 2 blue points are equidistant from that point. Now if I take my compass and go from each of those points, and make a few more points that are equidistant. I'm going to go through right there and down here. I'm going to go through here. Here, I didn't bring that one down far enough to line up. I'm going to draw this one in blue for you so you can see it. Okay. So, I have 3 altitudes. I've done it. And they all cross at one point right there in that middle. That point right there is called the orthocenter. Okay, we did it. Now we have a special situation. This triangle, you know, it looks very similar to a 60-degree triangle, an equilateral. All my angles are less than 90 degrees. So it's different from this one because what happens here is I have an obtuse angle. So how is that going to change things? If you remember, when you're looking at this triangle oriented in this direction, your height is going to come straight down like this. But what if you're looking at it in this direction? It's sitting on the ground here. Where is my height going to be? If this thing is sitting on the ground like this, how do I find the height of that triangle? It's got to be perpendicular and it's got to go through that vertex. So it's really going to end up being something like this. Remember this? We used this when we were doing area of triangles the same way. So same thing, We're still gonna draw a perpendicular to this line. It's still gotta run through that point, but we're gonna have to use the ground to help us out here. Let's bring this in a little bit. Got a point there and a point there to work from. Here and here. All three of these should line up if I did it right. That's good. Okay. So there's the height of my triangle right there. So this one, it looks a little weirder. If I went from the other side, you're gonna end up in kind of the same situation if I look at it from this angle. And this is my ground here that it's sitting on. Where is my height gonna be? It's not gonna be inside the triangle, it's gonna be, you know, over here somewhere, right? So let's see if we can figure it out. Use the ground to help you. You've got to have somewhere to put those 2 points that are equidistant from your vertex. Why did my compass out enough to get a couple of decent points? If I get them too close together, it's harder to see where they cross. Okay, I'm going from here. I've got my 2 points I'm going to work with now. Line up for me. That's it. Okay. Right there. That's the height of my triangle. From that vertex, when I drop a perpendicular, it doesn't land inside the triangle, it lands out here on the ground. But that's fine, that's still the height of my triangle. Okay, then the easy one, of course, is the one we talked about at first, when it's oriented straight up and down, kind of easier to see. Basic height. All right, here we go. We need 2 points equidistant from that vertex. And then we're gonna make our arcs that are both equidistant from those points, and that will give me a perpendicular. Okay, I have an altitude here, I have an altitude there, and I have an altitude there. This is kind of a weird case. I just wanted y'all to see that sometimes this happens. This was a nice, neat one. The orthocenter's inside the triangle. This is a weird one because it's an obtuse angle. Where does the orthocenter actually occur? If I drew this height out here on this perpendicular, I'm actually going to have to extend this out for you to see where these intersect. This one on Sunning out. And this one. Make it a little bit longer too. They do actually meet right there. It's like the tip of my TP. That's the orthocenter for this bottom triangle. Even though it's way out there, it happens when you're doing an obtuse angle in your triangle. Okay. Number 1 says, find the orthocenter of the triangle using your compass and straight edge. Then measure as accurately as you can the height from each side of the triangle using each of the 3 altitudes you drew and each side length. Okay. Measure in centimeters. Calculate the area 3 different ways. Okay, rather than me do that on this triangle and work through that just for the sake of showing you guys faster, I'm going to use this one I already made. Okay, let's look at the triangle from this angle. We're going to do it from 3 different angles. Okay, so I did my height there in blue. That's my altitude. And this will be my base when I'm looking at it in this orientation. I know the area of a triangle is 1/2 base times height. So here we go. Let me measure this base. And it looks like 7.7, I think. And this height looks like 7 point. It is very close to 7.6. I don't know, guys. It could be like 7.57 or something. But, you know, I can only do what I can do here. So let's figure out if we're using this is our height and this is our base. What is this area going to be? And your triangle is a different size than mine, so your numbers are going to be a little different. It depends on the size of your triangle. Don't expect the same exact measurements here. We just follow the same process, okay? 1/2 times 7.7 times 7.6. And I should have used wigglies there too, because you know our measurements are not exact. I get approximately 29.26 square units. Okay. I'm supposed to do it from all 3 sides and check and see how similar my answers are. So if I do it from this side, this is my base. Right, and I can see that little right angle I drew right there. That's my height. Okay, so let's measure. There's my tip. That looks like exactly 6 to me. And this base, I'm gonna guess that's 9.8-ish. So let's try that one. Area equals 1/2 times 9.8 times 6. 9.8 times 6 divided by 2. Approximately, because because we did measure ourselves and our eyeballs and our measuring tools are not super accurate. 29.4 square units. And then if I turn it, the third orientation. You see where I made my altitude earlier? I put that little 90-degree mark there to mark it. So that's my height. And this time I'm using this side as my base. Okay. So area is 1/2 of, my base looks like 7.8, I'm guessing. It's pretty close. My height looks like I'm going to go with 7.6. Alright, let's see what that is. 7.8 times 7.6 divided to 29.64. Okay. Well, you can see 29.64 is the largest one I got. 29.4 is kind of in the middle, and 29.26 was the smallest one I got. So I got a little range, and that's okay because we can't measure that exactly perfect, but they should all be really close to each other.